Hi, my name is Jackie, and today I'm going to be doing my tutorial video on correlation. So correlation is a relationship between two variables represented by the ordered pairs of x and y, x being the independent variable and y being the dependent variable. So the correlation coefficient is a measure of strength and the direction of a linear relationship between two variables. The symbol R represents the sample correlation coefficient. And a formula for R is, as I wrote below, it's kind of lengthy, but when you plug the numbers in, it actually is not that hard to do, but you do need to do it with a calculator. So the formula, the top is going to be n, which is the number of pairs in the data, times the sum of xy minus the sum of x times the sum of y, over the square root of, again, n times the sum of x squared minus the sum of x squared, times n times the sum of y squared minus the sum of y squared again. And I have the following example. So the number of hours 6 students watched television during the weekend and the scores of each student who took the test the following Monday. So I made a little graph, and so the hours spent watching TV would equal x, and the test score was going to equal y. So, and then I also drew a little scatter plot, so you can see that the correlation is actually going to be positive because it's going upward, but we'll get to that towards the end. So how to calculate this? I drew this table and I did hours spent watching TV, which is x, test scores, which is y, then we have to find x times y, then we have to also find x squared and y squared, and I drew it out as the following, and I got the sum of x is 14, the sum of y is 507, the sum of xy is 1111, and the sum of x squared is equal to 48. The sum of y squared is equal to 43,359. And we, like I said before, we know that there are 6 pairs in our data. So I computed the problem and I got that approximately negative 0.808 was my correlation coefficient. So now we know that the range of the correlation coefficient is -1 to 1. If x and y have a strong positive linear correlation, R is close to 1. If x and y have a strong negative linear correlation, R is close to -1. And also, if there is no linear correlation or a weak one, R is close to 0. So I would say in our example, going back to the scatter plot, we know that our R is going to be -0.808, and our scatter plot is going in a positive direction. And we also see that from -0.808 is closer to 1. And that concludes my video. Thank you.